Good day, grade 12s. Today is the 30th of September. We'll be looking at technical mathematics. Under technical mathematics, we are having circles and angular movement. That is the topic that we are going to be discussing for this lesson. And then remember, we are now we are done with the trial examination. I think all the provinces have done writing the trial examination. We are now preparing for final exam. So let us make sure that we keep all the important information under technical mathematics, and then we make sure that we touch every concept under technical mathematics. That is going to help us to perform very well under technical mathematics. But we are behind you, boys and girls, that we believe that you are going to make us proud. But let us make sure that we focus 100%, and then for this coming exam, yeah. So let us start with our lesson for today and see what are we going to be learning. Under content, we are having circles, angles, and angular movement. That is the topic that we are going to be discussing for today's lesson. But you will remember that this topic, it was done in grade 11. But it's very important because it's part of the exam for grade 12. And then remember, this topic is also form part of paper 2 for technical mathematics. Now, under circles, angular movement, then we'll be looking at degrees and radians, where we'll be learning on how we convert from degrees to radians, vice versa from radians to degrees. So you must be able to know that information. And then from there we move to sectors and segment, where we'll be calculating the area of a sector. You must also have, you must also remember that. And the last one is angular and circumferential velocity. So this one of circumferential velocity is sometimes called peripheral velocity. Then we'll be calculating those as well, angular as well as the circumferential velocity. So those are concepts that we are going to be focusing on for this today's lesson. Then we'll start with measuring angles in degrees. Under measuring angle and degrees and radians, we can measure angles in degrees and or radians. A radian is a measure of an angle that indicates the relationship between the arc length, and the radius of the circle, converting between degrees and radians. So you must be able to be very flexible on converting the degrees to radians, and then vice versa. And then it says the size of the central angle. The size of central angle, which is theta, is found by dividing the arc length S by the radius with the radius length, which is R. Now for if you are in need of the central angle, then you are going to be using this formula that says theta equals to what? S, which is the length of arc, and divided by the length of radius, which is R. So that is the formula that we are using to calculate the central angle. Then I'm going to explain at the later stage when we are talking about the central angle, what are we referring to? Then I will explain that later. And then this is the formula, theta equals to S over R, all right? And then they can also ask you to calculate S, which is the arc length. So if that is the case, then you'll have to make S the subject of the formula. So what are we going to do? You can now cross multiply, then S is going to be equals to what? Equals to theta multiplied by R. So that is the formula if you have to calculate what? If you have to calculate the length of an arc, right? The same applies with R. If you are in need of R, which is the radius, you can also cross multiply and make R the subject of the formula so that you can be able to calculate that. And then the next step we're having what? To convert the angle from degree to radians. We then multiply that degree with pi over 180. So every time when you have to convert degrees to radians, then you multiply by pi over 180. And then if you then have to convert what? The radians to degrees, then we multiply that radian with what? With 180 over pi, if you have to move from radians to degrees. But now under this topic, we normally use radians, all right? We normally use radians to calculate anything. So if the angle is it is given in terms of degrees, we always convert it to radians. We always convert it to radians. But sometimes there might be a question that asks a learner to convert from radians to degree. So you must be able to do that as well. But now, like I said, that for this topic, we normally work with radians. So make sure that you are 100% sure on how to convert from degree to radians, because we are going to be using radians. So if you are given the degrees, convert that degrees to radians, all right? Now let's see on how do we convert this one. Convert 4 degrees, radians, 4 radians to degrees. Then this is the solution on how do we do that. Then you just say 4 times what? 180 over pi. Then the answer is going to be in terms of degree, which is 229,180 degrees. So that's how you should now convert a radian to degree. Very simple and straightforward. Now converting 185 degrees to radian, you just multiply that to 185 degrees by pi over 180 degrees. Then the answer is now, it is in terms of radians, which is 37 pi over 36. So just make sure that you don't mix the two, because sometimes learners, what they do, they will just mix this 180 over pi, thinking that he or she is doing the right thing, whereas it's mixing the two. Just make sure that when you are converting from radians to degree, it's 180 degrees divided by pi. That's what we are using. And then for degrees to radian, we are using pi over 180 degrees. So don't forget that. Don't forget that, because now by the time you are going to be answering question, for instance, if you had to calculate the area of a sector, or when you have to calculate the angular velocity, or the angular circumferential velocity, then you make a mistake of converting degrees to radian, then the answer that you are going to be getting is going to be wrong. So you might get 0 for that particular question, because now the radian that you were supposed to calculate is not correct. Because why? You did a mistake of multiplying degree with pi over 180. So let us make sure that we remember very well on how do we convert degrees to radian. It's very important. The sector of a circle. Let's now read to understand what is a sector. A sector is a region of a circle closed by the 2 radii of an arc of the second, right? Which is this one. No. All right. The sector can also be referred as a wedge or a slice. The two radii divides the circle with two sectors. The major is called the major sector and the minor sector. You can now see this circle here. We have the major sector, meaning is this portion, the gray one. It is shaded with a gray color there. That is it's a sector of a sector there. And it's also called a major sector. Then the minor sector is this small portion, the slice, so which is shaded in with black. That is the minor sector. And then the formula that we are using to calculate the area of that particular sector, it says area of a sector equals to 1/2 r squared pi, meaning then you will be getting the area of this portion here, the area of this slice, the area of that slice. Then that formula is going to help you to determine that area there. All right. And then like they are saying from this scenario that they're enclosed by two radii, meaning we have the first radius and the second radius. So that part which is formed by those two radii then is called a sector in that using this. If you don't have and what if you don't have theta there, you can use this formula to calculate theta. But if for instance you are having only arc length and you are also having a radius, and then you don't know what is the angle there, and then the question asks you to calculate the area of a sector and you don't have a theta there, then you can use this formula to calculate theta. Is very important, where S is the arc length and R is the radius, and S, of course theta is the central angle. So when you talk about the central angle, where we normally referring to this this one. Let me just clean here. So is the central angle, the angle which is formed between the radii. That is the central angle that we are referring to. Yeah, that is the formula. So then we'll get a question where we are going to be calculating that the area of a sector. Let's see what we are going to be getting that. Show that the area of the shaded sector is now this. Now in this case, they have already calculated the area of a sector, so we just have to prove that answer, which is 231 meters squared. Then we'll have to calculate the area of a sector with this one, meaning we are going to be calculating the area of this part here. Let me just try to highlight it so that you can be able to see which part is that. This side, this one here. Okay, this portion, right? Yeah, we will be calculating the area of that, and then now they've already determined that area. We just have to prove it. Then let's see on how do we calculate that. Now first, because now, like I've said, if you are being given the area, I mean the angle in terms of the degrees, we always convert it to radians. So let us do that. Let us convert, then you multiply that degree with pi over 180. Then the answer is going to give us 3 pi over 4. So now our theta is in terms of radians. Then we can now be able to calculate the area of a sector. You write the correct formula for that, you substitute the values, you just press your calculator, then it's going to give us that value, which is 231 meters squared. So that's how you should calculate the area of a sector. And then number 2, it determine the area of a minor sector. Let's see. You can see we're having 2 sectors there, the minor and the major, and then we discuss the minor as well as the major. That now, if they are talking about the minor sector, meaning this small portion, there's this slice, then we'll be calculating the area of that. But now the question it says leave your answer in a pie form. Then I'm going to explain on how do we write our answer in a pie form. It's very important. Then let's proceed. First, we have to convert 60 degrees to radians first, and therefore then we're going to have this where we're going to multiply 60 times pi over 180. Then the angle in terms of radians is pi over 3. That is the angle that we are looking for in terms of radians. We can now write the correct formula for area of a sector, and then which is 1 over 2 theta over, 1 over 2 pi r squared. And then that's how we substitute. And then the answer is going to be 625 over 6 pi. Now, for you to be able to get your answer in terms of theta, now by the time you press your calculator, you don't include this pi. You don't include at all, because once you include the pi, the answer is going to be in terms of decimal. So it's not going to give you in terms of what? In terms of pi. So the best way to do this is to take this pi and put it aside, and you just press your calculator and say 1 over 2 multiplied by 1 over 3 multiplied by 25 all squared. Then it's going to give us 625 over 6. Then you just put pi there. Then your answer is in terms of what? In terms of pi. All right. The top view of a welding workshop is shown in the diagram below. You can see that's the top view of a welding workshop. It consists of a rectangular portion of length 5 meters and 60 degrees circular sector with radius 3 meters. You can see that. And there's a piece of what? It's a piece of slice. We can see that ECD is a piece of slice. Then we've got angle there. We've got the radius, which is 3. The first question that we have to address is to calculate the length of the arc DE. The length, we are looking for arc length now. This is the length that we are looking for, DE. So we'll be calculating the arc length. Remember the formula to calculate that. Let's see. That is the formula that we are going to calculate. Theta equals to the length of arc divided by the length of radius. But now, remember we are in need of this arc length, which is S. Like I've said, that we are going to make S the subject of the formula. So this is what we are going to be getting after doing that. So it's S equals to theta and R. Then we have to first convert 60 degrees to radians. Then by multiplying that with pi over 180, then it's going to give us what? It's going to give us pi over 3 multiplied by radius, which is 3. Then you just press your calculator. The answer is 3,14 or pi, right? That is the length for DE. That is the length for DE. And then hence determine the perimeter of the workshop. Now, what is a perimeter? Remember, perimeter is the total length of the sides, of all the sides, the total length of the sides. Meaning, for us to obtain the perimeter, we must add all the sides so that we can get the total length of the perimeter. Now we are going to say perimeter of AB. That meaning we have to get the length of AB and then the length of what? BC and then CD and so forth. Then we then say AB is 3, because we can see that the length of CD and CE are equal, which is 3 meters. and you can see from this rectangular portion, we know that the length of CE equals to the length of AB. The same applies with the length of AE is equals to the length of BC. Hence we say this is 3 meters there, and then BC is also 5 meters because we said these opposite sides they are equal in terms of length. And then of course we've got CD, which is 3 meters, and then we have just calculated what this arc length, which is DE. It was 3,14 plus 5. Then now the total perimeter is 19,14 meters. So that is the total perimeter. The third question, calculate the area of a sector CDE. CDE, meaning we want this portion, the area of a sector, and that is the formula. You just substitute because the area, the angle that we have converted, which was 60, now in terms of radians, it was pi over 3. Hence you see pi over 3 there. Radius of course is 3. Then you just press your calculator. Then it's 4,71 meters squared. And the other issue that I want to emphasize is the units. Every time when you answer a question, try to write units to show that to show us that you are calculating, for instance, area must be in terms of meter squared, depending on the units that we are given. If sometimes it's centimeter, it's going to be centimeter squared. So the units are very important. Sometimes you might not get a mark by just eliminating or removing the US or forgetting to write the units. So you might not get that answer or that mark, although the answer is going to be correct. But the fact that you did not write the units, then you're going to forfeit that mark because you did not write what the unit. An engineer is installing 2 pulleys with center A and B. You can see A and B in a machine as shown in the picture below. The 2 pulleys have radii of 50 centimeter and 20 centimeter respectively. You can see from these 2 circles which one has the radius of 50, which one has the radius of 20. It's obvious the bigger one is 50 centimeter and the smaller one is 20 centimeter. And then the center A and B of a pulley are 120 centimeter apart, and the length of the driving belt from K to L, which are points of contact, is 110 centimeter. It is further given that K angle A B is equals to 70 degrees and reflects K angle A D is what? Is 220 degrees. And then it says where S1 is the arc length of pulley A. You can see this is the pulley A, the arc length. And then S2 is the arc length of a pulley B. Now determine the magnitude, the size of A angle BL, meaning we need this angle here. A angle BL. So we are in need of this angle. And then the hint says AK, which is this line, AK is parallel to BL. So you should always remember if 2 lines are parallel, what does it mean? And then let's see on how do you answer this question. Then we're going to be saying that angle is 180 minus 70, and then the answer is equals to 110. Why 180? Because these 2 lines, which is KA or AK, is parallel to BL. And then we all know that this angle here and this angle they are called co-interior angles. And then pointer angle, they are supplementary, meaning they add up to 180. So meaning if this angle here is 70, to get this angle, we're going to say 180 equals to 70. So they add up to 180. So we're going to say 180 minus 70 degrees, then it's going to give us 110 degrees. So that's how you should obtain that angle there. Total length, determine the magnitude of A angle B L. A angle B L, we've determined that. And the last question, determine the total length of the driving belt with arc length S2, which is this one. We are now given that, which is 48,8 centimeter. Now we need to add all the length for this belt so that we can now get the total length. And then we are saying the length of KL. Where is KL? It is given that is 110. You can know that. And then the length of arc S2, it is also given, which is 48,8 centimeter. And then the length of DE, the length of DE is also 110 centimeter. You can see the length of LK is equal to the length of ED. They are equal. They are also equal. And then we have to calculate the arc length of S1, because now we don't have the length of S1, so we'll be calculating that arc length. And then we're going to use the formula to calculate that, which is S equals to pi over R. Do we have angle there? Yes, but now it is in terms of degrees. We have to convert it to radians. So it's going to give us 11 pi over 9. And then we then substitute, because we are told that the radius of the bigger circle is 50 centimeter, then hence we are having 50 there. You just press your calculator, then the answer is 192 centimeter. Then now we can be able to add all the sides so that we can determine the total length of the driving belt. Then you can see, and then the answer is 460,8 centimeter. 460,8 centimeter. So that's how we should determine what the length, the total length of the driving belt. A mechanical technician needs to replace the cross belt on a lathe machine, as shown in the picture below. The two pulleys have radius of 35 and 85 respectively, and the length of the driving belt A and F and C to D, A to F and then C to D, which are points contacts with 180 centimeter. Now we can see from these two pulleys that the radius of the 35, of course, is for this one the smaller pulley, and then this one of 85 is the bigger pulley there. So that is the radius. So this is going to be the radius, which is 85. This is 85. And then this one, of course, is 35. Now, the first question that we have to answer is, say, calculate the length of the major arc DF. Where is DF? This one, the major one. We need to calculate the arc length of DF to the nearest integer. Let's see on how do we calculate that. We have to calculate the arc length of DF, but we have to convert. We have to first convert 270 degrees to radians. Let's do that. We multiply by pi over 180, and then now the angle is in terms of radians, which is 3 pi over 2, and then from there we write the correct formula for that to calculate the arc length. Then we substitute the values, because now we've agreed that the radius for that bigger pulley is 85, and then the answer is going to be 4001 a centimeter. And then the second question, if the length of the major arc AC, which is this one on the smaller pulley there, the major arc is AC, this one, and then is 165 centimeter. Determine the total length of the driving belt to be replaced. Now we need the total length of that belt. But we first have to do what? We are now given the length, so we just have to add all the sides to determine the total length of the driving belt. And then we say 4001 plus 165 plus 130. You can see from D to C is 130, from F to A there is also 130. Then we add them together, then the total length for that driving belt is 4,426 centimeter. So that's the total length for that. And then we move to angular and circumferential or peripheral velocity. They are saying angular velocity is measures the velocity at the center of the turning wheel or a disc. It is a rate at which revolution the whole cycle measured in radians are formed. The angular velocity which is this sine, which is omega, is a measure of how fast the wheel turns. And angular velocity is the measure of the angular displacement per unit of time. The units for angular velocity that we are using is revolution per second, which is, can write it in this manner, which is rev per second, and then, or we can use radians per second, which is rad per second, right? So that is the units we are using when we are calculating angular velocity. Now we have a formula for that, which is velocity equals to 2 pi n, and then the other one is angular velocity equals to what? Theta over t, right? And then where n, we all know that pi, we all know pi. And then what is n? You can see n is the number of revolution per what? Per second. So we always have to calculate angular velocity in terms of a revolution per what? Second. But now if it is given in per minutes, we will always convert that. We will always convert that depending on the question once. And then we move to circumferential or peripheral velocity. It is the speed at periphery of a circular part due to its rotation. That is the speed that we are calculating. Now the formula for circumferential velocity is V equals to what? Pi dn, where d is the diameter of the circular part, and then n, of course, we said is the number of revolution per second. Or we can also use this one, where now is circumferential equals to angular velocity multiplied by r, which is the radius. So that is those formula that we are going to be using when we are calculating angular velocity, or when we are calculating circumferential or peripheral velocity. Now let's get a question and see on how do we calculate that. A flying wheel is rotated at 10 revolution per second. Determine the angular velocity and round off the answer to 3 decimal places. We then have to calculate the angular velocity. We write the formula there, because now in this case we can see we are only having 10 revolution per second. Then we're going to use this one. Remember, we also have the formula to calculate angular velocity, which is pi over t. You can see, not pi over t per se, but theta over t. And we don't know that we don't have the angle in this scenario. We don't even have time. So we only have this one. So we are going to use this one, and then just substitute the values there, which is 10, and then the answer is going to be 62,832 radi per second. Number 2, generator pulley rotate at 3,000 revolution per minute. We can see that in this one, it is given in terms of what? revolution per minute. Now, question says calculate the angular velocity in radians per second. Can you see the question? It needs the angular velocity in terms of radians per second. But now we are having 3,000 revolution per minute. We'll have to convert that first. Let's see on how do we convert that. We are going to say 3,000 divided by 60. Why 60? Remember, per minute. 1 minute is equals to how many seconds? 60 seconds, right? Hence, we have replaced 1 with 60 because now our question needs us to calculate angular velocity in terms of what? In terms of radians per second. Then you just press your calculator and the answer is going to be 314,2 radians per second. That is the correct answer. And then number 3, the pulley of a machine has a diameter of what? 900 millimeter, and it rotates at 2,000 revolution per minute. Calculate the speed of the belt passing over the pulley with in meter per second. In meter per second. And run off the answer to the 3 decimal place. Now you can see from the information that we are giving, first we are giving diameter in terms of millimeter. And remember the answer that we are supposed to get, it must be in terms of meters, not in millimeters. Then we'll have to convert first this 900 millimeter, and then secondly, then it should be in per second, not per meter, not per minute. But now it is given in terms of 2,000 revolution per minute. Then we will also have to convert that. Then let's see on how do we do that. Convert the diameter first, meaning 900 millimeter to meters is going to be equals to 0.9 meters. And then we write the correct formula for circumferential or peripheral because we are calculating the speed, and we also explain what is the circumferential or peripheral. Then we substitute because now this revolution per minute, we had to convert it to per second, then by dividing with 60. Then I also explain why 60, because in this case it say 2,000 revolution per minute. So 1 minute we change it to seconds, so it's going to be 60. Hence we divide with 60. From there you press your calculator, then the answer is 94,248 meter per second. So that is the circumferential. The picture and the diagram below shows an electric fan that has 4 identical rotating blades that rotate at 160 revolution per minute. Circumferential velocity of the tip of the blade is 32/15 pi meters per second. They determine the numerical value in meters, the radius of the blade. They are now in need of the radius, and you can see from the scenario we're given the circumferential. And then if you remember very well the question, the formula, it does have diameter, which is V equals to 2 pi dn. Let's see on how do we calculate that. Pi dn, sorry, is V equals to pi dn. Then diameter, then we can calculate the diameter, and then thereafter we know that a radius is half of diameter, and then we can be able to calculate the radius. And let's see, V is the circumferential, which is this one. We are now giving that value, which is 32/15 pi equals to pi d, and then now n. Let's see n. And it is given in 160 revolution per minute, but now we need to convert it to seconds. Hence we divide 160 over 60, and then we divide both sides with pi over 160 over 60. This is what you do, so that you can now make the subject of the formula. You press your calculator, the answer is going to be 1 meter. 1 meter, that is the diameter. But now and we agree that radius is half of that, so it's going to be 0.5 meter. So that is the radius. Number 2, angular velocity in radians per second. Angular velocity in radians per second of a rotating blade. We now have to calculate the angular velocity. You write the correct formula for that. You then say 2 pi. Then we agree that this we have to calculate in terms of revolution per second, not per minute. Then hence we say 160 over 60 there. And then you just press your calculator, and it's going to give us 16,76 radians per second. A pulley rotate at 420 revolution per minute. Calculate the angular velocity of a pulley in terms of radians per second. Then we also have to convert that. Let's see. You write the correct formula for that. You then convert revolution per minute to per second by dividing with 60. You press your calculator. The answer that you're going to get is 43,98 radians per second. Second question should calculate the circumferential velocity of a pulley in meters per second. If the radius of a pulley is 242 millimeter, then now we can see that the question it needs us to calculate the circumferential velocity in meters per second. Now the diameter that we are having now, it is in terms of millimeter, which is 240 millimeters. We had to convert that first, which is 240 divided by 1,000 when we convert it to meter. So it gives us 0.24 meter. And then from there we substitute the values. Then you press your calculator. Then the answer is 5,28 meters per second. So that is the correct answer for circumferential velocity. A windmill, as shown in the picture below, has a rotating blade with a radius from the outer edge of the blade to the center of 75 centimeters that rotate at 45 revolutions per minute. Calculate the following rotating blade, the circumferential velocity in meters per second. You write the correct formula, but we have to convert what? The 75 centimeter, because now the answer we have to answer circumferential in terms of meters per second. Then we have to convert centimeter to meter, which is we divide with 100, then it's 0,75 meter, and then we then proceed. Then we also have to now convert this 45 revolution per minute to 45 revolution per second. Then now we divide this 45 with 60, because 1 minute is equals to 1 minute is equals to 60 seconds. All right, then you just press your calculator there. Is 3,53 meters per second. Second question, the angular velocity in radians per second. You write the correct formula there, substitute, and then you press your calculator. The answer is 4,71 radians per second. So that's how you should now calculate this. So, but this I think is quite easy. And then remember, grade 12 is that we does have this formula and the formula sheet. So you just have to know when to use this formula. That is very important. And then also converting, it must also be you must also be very, very confident when you have to convert. So you have to learn on how to convert as well. The mid-ordinate to determine the area. Determine the area of an irregular figure using the mid-ordinate rule. So this is the formula that we're going to use to calculate the area of an irregular figure. Now let's see how do we do that. The irregular shape, you can see this irregular shape is shown below as one vertical straight side. 3 meter long, which is divided into 5 equal parts. The coordinates divide the part are 70 centimeter, 90 centimeter, 120 centimeter, 49 centimeter, 80 centimeter, 30 centimeter, and then write down the length of the equal parts. Meaning we want to know what is the length from here to there, from there to there. We want to know what the length. So now, in order to determine that, let's see the length. You say the total length, which is 3 meter, divided by the equal parts. So in this case, you can see how many parts: 1, 2, 3, 4, 5. It's also given from the scenario that is 5 parts. Then you're going to divide the total length with those equal parts, which is 5 parts. Then it's going to give us 0.6 meter. Meaning from the first ordinate, which is 70, to the next ordinate, which is 90. The distance there is 0.6, as well as 0.6, 0.6, 0.6, and the last one is 0.6. Now the next question, determine the area, but now in terms of meter squared of the regular shape by using the ordinate. Now we first have to convert, because now we can see the ordinate that we are given, it is in terms of centimeter. So we had to convert them first to meter. And let's see, then to convert centimeter to meter, we divide with 100. So it's going to give us 0.7 meter, 0.9 meter, 1.2 meter, 0.49 meter, 0.8 meter, 0.3 meter. So we have converted all the ordinates. Then we can now determine the mid-ordinate. Let's now determine the mid-ordinate. You take the first 2 ordinates, you divide by 2, then it's going to give us 0.8 meter. The second one, you add them together, divide with 2, it gives us 1.05 meter. The third one, you take the 2, 1.2 plus 0.49 divided by 2, give us 0.845 meter. And then the fourth one is 0.49 plus 0.8 over 2, it equals to 0.645 meter. Of course, the last one, which is 0.8 plus 0.3 over 2, equals to 0.55 meter. So that is the last one. So this, we have determined the mid-ordinates, right? And now we can now use the formula, which says the area equals to the width of interval multiplied by the sum of the mid-ordinates. Now we have determined the width of interval, which is 0.6. And then, of course, the sum of mid-ordinates, we have determined that. You just put everything on the formula there. You just press your calculator. The area that we have determined is 2.334 meters squared. So that's how easy it is to calculate the area of a regular figure. All right, thank you very much, my dear learners, for being with me on this interesting lesson. Let me just leave you with this words, which says, our greatest weakness lies in giving up. The most certain way to succeed in life is always to try just one more time. I thank you. Thank you very much. Have a nice evening. Bye.